When the sun goes down, the forests of Ontario come alive. Tiny wings flutter through the night, chasing insects and navigating with sounds we humans can't hear. These are our bats. But over the last decade, many have been disappearing, leaving 7 out of 8 species listed as endangered in our province. Ontario bats are vital to maintaining balanced ecosystems. Every night they eat thousands of insects, helping forests, farmland, and crops stay healthy. Protecting these cool, elusive creatures of the night is critical, but it's not easy. Bats are small, fast, and nocturnal, which makes it hard to know where they are. That's where acoustic monitoring comes in. Acoustic monitors use specialized microphones that can record the ultrasonic echolocation calls bats make to navigate and hunt in the dark. These monitors are placed out in the habitat where bats are active to passively record their calls over long periods. This method is especially powerful because it lets us survey bats across huge areas, places where physically trapping or observing them would be nearly impossible. Each species of bat has its own unique sound pattern, almost like a fingerprint. Using specialized computer software, researchers like myself can identify which species are present even without seeing or hearing them. My name is Alana Limburner, and I'm a field conservation steward at the Toronto Zoo. And I've been working on a project using bat acoustic data collected from a large team at the Ministry of Natural Resources at 61 sites across Ontario's boreal forest over a 4-year period. One of the largest studies ever conducted in this region, covering roughly 45 million hectares, a massive stretch of wilderness. This large data set was then shared with us at the Toronto Zoo. Science really is a team effort. Using our bat expertise and specialized software, we transformed echolocation calls into maps to show where bats are most likely to occur and which environmental factors influence their distribution. But creating these maps isn't as simple as plotting points on a screen. To make accurate predictions, we use statistical software and a method called occupancy modeling. This approach estimates the probability that bats are present in an area, but it also accounts for the fact that we might not always detect them. Just because we don't record a bat doesn't mean it isn't there. Maybe it flew too high, too far away from the microphone, or simply didn't make any calls that night. Occupancy models need 2 types of information, called covariates. First, there are site-level covariates, and these are details about the exact spots and time bats were recorded. These include what type of detector was used, what the habitat was like right around it, and when that recording happened. Then there are survey-level covariates, which tell us about the environment around each site. This could be the temperature or what types of habitat are in the surrounding area, factors that ultimately influence whether a bat is likely to be present. These factors help the model figure out 2 things. 1, how likely we were to detect bats if they were there, and 2, how likely bats are to actually live in that area based on the habitat. Once we understood these factors, we could predict where bats are likely to be across Ontario's boreal forest. We divided the forest into 10-kilometer grid cells and looked at the mix of habitats and conditions in each one. The model then estimated the chance that bats are present in each cell, showing patterns we could never spot just by visiting individual sites. The result? Maps showing where bats are most likely to live. Darker colors indicate a higher probability that the species is there. For example, silver-haired and hoary bats have the most blue, and therefore have the highest predicted occupancy across the region. These maps are powerful tools. They help us figure out which areas are most important for different bat species, guide conservation decisions, and protect these amazing animals across one of Canada's largest ecosystems.